So once you are applied the formula, this one is equal to this one plus a is. So this Now you are trying to apply you have considered some of you for that also marks given. Some of you have considered this is your x-axis and this is your y-axis, because if it is x-axis, y-axis should be making 90 degree. This is not your y-axis, so this is your y-axis. This angle is 90 degree. Okay, and after that you have considered this is your cos 75 degree, and this you have considered sin 75. Okay. After that, when you are going to apply the equation, kinematic equations, there whatever condition you have put, all conditions are wrong. Clear? So there was no base of considering those values for these variables. Suppose you are going to utilize this equation, so there you have made a base. So ultimately answers are not correct. Your states also were not correct. So there was no scope of providing any part one. Part one you provided still. One was provided for writing each component correct. After that no scope. Because this kind of numericals, especially there is no chance of doing any mistake. In the final calculation you will do mistake. That is something different. But before that, all the people diagram, all those steps should be written correct. Clear? So you may have not most of them you have done because this side Newton meter and this side Newton, how they can be equal? Left side is the unit of the quantity is Newton meter, right side quantity also is Newton meter. And finally what happened? All of you have written correct answer. In the next slide you have written correct answer. Previously all written rubbish. Clear? So be very careful. You should solve those problems because this is a very common type of problem. And that problem, the second problem from my part, you have not drawn the free body diagram, most of it separately. So here there was a free body diagram for this side tension T, here W of mass, the body is black, here so RA, and after that many of you have forgotten to give your function FA or like that, functional force. Okay, now when you have drawn this free body diagram and that is placed on the horizontal surface, it is moving in this direction, so inertial force is written drawn in this direction. After this is okay. After that what blunder you have done, because you have not been understood or you have messed up with the work energy principle. One problem was done using work energy principle is a inclined plane. Here together we are considering because it is solved by VR method and that is the method of work energy principle. Completely different. So what equation, wrong equation you have written here? Suppose this side is moving, so this is you have written correct. E minus of those frictional force. Okay, so this is your net force minus resultant mass of A plus mass of why it is coming. You have drawn for body A, so here it will be only mass of A. From where? Because when you are drawing the free body diagram, when it is connected with a string, here is a pulley, and after that here is a block. Now you are drawing free body diagram of two bodies separately. So whatever coming in the free body diagram, what data is present, that is right. So here it should be only MA. Here we will MA plus it. Here. So that is the case. And another common mistake you have done. Regarding to find out Ix, Iy, Iz. Clear? So here one is given like this. Suppose this type of ring element was given. Now many two or three students have done correctly Iz. Integration is equal to integration. Iz integration what? What? What is Ix? Forget about this. What is rectangle? G and H, Ix. So this is your centroidal axis. This is is your vertical centroidal axis. Okay, so ISS, how do you find? You have to consider an element here. So like this. So this element at a distance y, thickness minus dy. Then what are you doing? What is ISS called? Moment of inertia of lamina. Lamina means its width and two dimensions are much larger compared to the third dimension. Thickness is very less compared to the length and breadth. Okay, so that's why it's called lamina. So for finding out the lamina, so if you put 1/1 lamina, then it will become a solid. So in that case also you have to find out not only moment of inertia, mass moment of inertia. That is also there in the syllabus. Now, what is the formula for ISS for lamina? Integration. For finding centroid, XC, YC. So moment of inertia, second moment. So integration ISS will be integration y square dA. dA is the element, area of the element. Simply here also, if it is given written x, no problem with the right x in place of r, then it is dx. So what is the dA? dA, what is the formula for dA? 2 by x into dx. Now most of you, those who have written this, here only you have written x square. Here only in place of dA formula you have written this. In fact, you have not written dA. You should write dA because it's a very small area. Most of you have written A. A means integration of dA. So that formula is not A. That formula is dA. You have not written dA. But after that also, what you have done? You have written there only that x square or r square term. But actually IZZ, when you are calculating, IZZ is equal to integration r square dA. So here r square is coming. R square is not coming in calculation of area. R square is coming when you are finding out the moment of inertia, not mass moment of inertia, moment of inertia. Here r square, that's why it is coming r cube. Here, so these kind of mistakes should not be repeated unless and until you practice. It is very difficult to improve because there is no chance of doing it. Every time you are writing a number or a variable, if any other mistake, final answer will be wrong. You cannot compare this subject with the other subject because it is mathematics based subject. इधर उधर होगा, final answer आएगा नहीं. But every time you should that's why write down the formula of theory you are applying so that you can get the part marks. That also you are not writing. You have written net force minus inertia force equal to 0. Here for that also what was given. In this way marks total becomes 6, 7, or 8. 2 and 3 have got 10. Now 4 and 9 10 for means then how suppose CH3 completely paid, you have paid means we have paid, so we cannot fulfill the course objective because we have not learned anything. So this is the assessment. So whatever is going on in the class, whatever output you will give, the students also will give that impression. Here, teacher is coming and teaching. After that, you know output is coming, then that is business teaching. Total is like this. If you don't study properly, notes are so, then there is useless teaching. down a 45-degree inclined plane. Roll number 16 আছে 16 medium টা ভুল করে বলে কমার পেজ হচ্ছে লাস্ট a 5000 Newton block slides down a 45-degree inclined plane. Stop. It starts from rest. After moving 2.5 meter, it strikes a spring. Whose modulus is 3030 Newton per millimeter. After moving 2.5 meter, it strikes a spring whose modulus is 30 Newton per millimeter. Full stop. If mu is equal to 0.25, determine maximum deflection of the spring and maximum velocity of the block. Now here is a screen. Here is the block. This distance 2.5 meter. So what question is asked? Very common question, usually 8 marks. So you have to write your the steps correctly, then you can get the marks, part marks. So here what data is given? Log A, mass of A 5000 by 9.81 kg. Okay. Log weight given 45 degree angle. This distance 2.5 meter and mu is given 0.25 and spring constant 30 Newton per millimeter. You know what is spring constant? What is spring constant? Do you know? From the elasticity chapter, if you apply a force to the spring, compressive force, what will happen? It increase or decrease? Decrease, compress. Clear? So when the spring is compressed by applying force, then suddenly if you release that force, what will happen? It will again regain its original dimension. The spring is compressed. That means that time it gains some energy. You have done some work on the spring by applying force. So what you have done, that is stored as an energy. Clear? And once again if you release that force, then again it will come back. So that energy will be released. What it has gained? Say if you apply tensile force to stretch it, then again it will release. Again it will contract to its original dimension. In both the cases, the spring is having is the second part. What is the first question? Find the maximum velocity. So definition of the spring and maximum velocity of the block. So block is sliding down. Here is a friction. Block is sliding down, and then it will touch the spring or hit the spring, and after that the spring will exert a resisting force. Still block will move little bit down the plane, and after that one moment will come, spring will be compressed. At the same time block will also stop. So the whole system will come to stop. Clear? So viewing the motion of the block A, can you tell when the block will have maximum velocity? From the figure, see the figure and then.
Sir, when the spring release is
No, it's moving down, using its downward journey. When the block A will have maximum velocity, it is coming down. Then it will touch spring. After that, spring will be compressed, and the velocity of the block will decrease or will remain same. Decrease. So at which position the block will have maximum velocity? Just when it is striking the spring. So at this location it will have maximum velocity. Right now. So if you consider this is P Q R. Sorry, PQ, and suppose it is compressed up to this is R. Okay, so it is compressed by how much amount? This is delta. So your question that when the velocity maximum of the block, how much delta? These are the questions. So you can easily see the velocity will be maximum at position Q. Clear? So this is suppose this initial position P, when it is right here, come here, that time velocity of the block will be maximum, and after that there will be resistance of the spring continuously, and the block will come to rest at position R. Not only block, spring will be at that moment will be in compressed state. System stops. Clear? So how to find the maximum velocity? You have to draw P-body diagram. How many P-body diagrams you have to draw so that you can have partners? Actually the whole journey from P to R, but the type of journey from P to Q is different from Q to R. So you have to draw the P-body diagram of the same block A how many times? 2 times. One for the path P to Q, another for the path Q to R. Because during Q to R motion, there will be extra force, resisting force, spring force, which is not present in P to Q. So for path PQ, then you have to draw the P-body of the block. Just how it is. Here you cannot change the configuration or orientation of the block. This way, then here it is how much? MA G cos 45 degree. Here MA G sin 45. MA G means how much? 5,000. Okay. And after that, it is sliding down. So here is a frictional force. That is mu into. Here is a reaction force. RA. So mu into RA. That is mu into MAG cos 45. This is the frictional force. Any other force? Any other force? You can solve this one also by the other, but we are going to solve using what energy? because here no one asked about acceleration. Follow? Frictional force due to air. Frictional force, this is the frictional force. Any other force present? No other force. Then just that one, that work done to move the block from P to Q, that will be equal to কি হবে এখানে কি হবে এই ছবিতে কাইনেটিক এনার্জি at q minus এটা লিখলে মাস পাওয়া যাবে এত তো বললে এটা কি বললে তবে গিয়ে মাস দেওয়া যাবে পরে এটা এবার এই ইকুয়েশন এই কতগুলো নাম্বার লিখে পুরো ক্যালকুলেশন where you get the part. Now you are finding. So we will consider here the direction of motion as positive because it is going up, so this is positive. So what will be the expression for the left hand side? Again a liquid. Then you go on writing the expression of this. Go on writing the expression of this. Go on writing the expression of this. And systematically answer to the down. First you write down the general equation, then you write down the expression for each one. So P to Q. So how much? You see what are the forces? Average is at 45. This is in the positive direction. So average is equal to calculation. Write down the value. 5,000 এখানে 5,000 আছে ঠিক আছে sin 45 right so average sin 45 হলো and this is in opposite direction to that of the motion so it will be minus u কত আছে 0.25 into cos 45 5,000 common নিয়ে নিচ্ছি okay so this is the net force into displacement downward how much displacement 2.5 so if you apply work energy principle in a single step you are going to get that if you apply real effort then first we find out acceleration then again you have to take a kinetic equation to find out the final velocity ঠিক আছে so এখানে kinetic energy at q find out kinetic energy how much half mv square m means 5,000 by g into v square so v is asked rather it is g max যেটা চেয়েছে v max square so half mv square আর at p
so এটা g max square কেন বলবো আচ্ছা
kinetic energy রেস্ট্রিকশন জাস্ট রিলিজ করে দেওয়া আছে রেস্ট্রিকশন ধরা ছিল so it is 0 তাহলে প্রজেক্টটা এক্সট্রা করে শুরু করা হচ্ছে এখানে শুরুতে ধরে নিতে হবে যখন আটকে গেলাম ধরে নিলাম যা বলে হচ্ছে কিছু হবে না so here it is release from rest so you are going to get answer so directly you are going to get only one unknown here v max square R. What's it? 9.1. Now for path. QR. Prof. এগুলো তো সব একই থাকছে। W cos 45, W sin 45 degree, reaction RA और मेरा डाटा सेट RA और उसी का रेगुलर भी सेम, so RA, okay, then here frictional force same, U into RA, whatever we have reported diagram is same. Now one extra force is acting in the spring. If you have not drawn that one, that means the whole program you have done out. You have spent 30 minutes, you have written in 2 pages, finally marks got out of 10, 1, 2. Then all get out of 75, 30. Minimum 30 you have to score. If you don't study properly, it also happens out of 30, internal 25 and out of 70, 7. And 20 out of 100, 37 or 32, something. Once you get something, it is very difficult because later on you will not get time. In the fourth semester, more like this type of numerical subjects, fluid mechanics, then strength of materials, then platform. Clear? So practice. Don't see only. It will not help you because when you are going to write, you will write something wrong. Clear? So that's why for these subjects you should write more. vector in this direction, so we have considered the side. Clear? So you can see there the spring force varies from 0 to k delta. 0 to k delta. Now how much work is done? Displacement is delta, and how much force? 0 to k delta. So how much is the force? Force varies linearly from 0 to k. So in the formula, that is force into displacement. That is the work done by the spring force. What is the value of force? Average force. Because the force is high. Average force means minimum value of the spring force is 0. Final value is k delta. Arithmetic mean. This is not in the formula. Clear or not? This into displacement. This is the force into displacement. So it becomes k delta square by 2. Is it okay? So how much is the force acting here? What you can write? Oh, so the work done. K delta by 2. Now again same, you have to write this work done to during the motion from Q to R. Right? Q to R is equal to kinetic energy final distribution R minus kinetic energy Q. Clear? Now we go on writing the expression of differential. Go on writing the expression of two terms on the right hand side. Clear? So what? Start to move from Q to R. See the free body diagram? Same. W sin 45 degree, that is acting downward, this is positive relation, minus mu RA. Mu means mu level. W cos 45, RA means cos 45, W cos 45 degree. Okay? So this into W sin 45 degree into this into delta. What? There is another one. That is the work done by the spring. Clear? That expression just now written. So spring force is acting in this direction k delta by 2 and the displacement in this direction delta. So k delta by 2 into minus delta. So it is equal to kinetic energy final. How much? This is 0 minus kinetic energy at Q. Already you have got half 5000 by 9.81. So the first answer is what is it? So 5.1. So this is what kind of equation? If you can arrange the equation like this one, you are going to get 80%. Clear? But you have to try each and every time, each and every term should be written correct. Then only. So, because after this, you should during the university exam you should use this. Clear? Because that calculation is better. But this equation should be written on this time. Because main thing that you can solve. After that, you can calculate and but what kind of equation is this? Quadratic equation. So finally the equation will keep taking the form of delta square h delta. So the unknown is delta. So it is a quadratic equation of variable delta. Clear? So sin 45 degree also four will calculate. Sin 45 degree also. So W by root 2 minus 0.25 into W by root 2. So W also 5000 given. So it will be calculated very fast into delta minus k you have to be very careful. 30 newton per millimeter remains. So you should write the value 30 newton per meter because we are using SI unit. So what is the value of A newton per meter? Newton per meter. नीचे डिनोमिनेटर का मिलीमीटर से मीटर बोल देते हैं तो कोई बात नहीं नीचे के 30 न्यूटन पर मिलीमीटर ये मिलीमीटर है तो वाले मीटर को स्टॉप दे दे এটা 1000 मिलीमीटर माने 8 मीटर so you can multiply with the denominator 1000 is also multiply with the numerator 1000 so it will become 30,000 newton per meter. Here in the numerator 30 newton, in the denominator 1 millimeter. So you want to change 1 millimeter to 1 meter. Denominator you multiply with 1000. If you multiply denominator with 1000, if the fraction says you have to multiply numerator with 1000. So you have to put the value of A 30,000. Here A 30,000 delta square by 2 so 30,000 means it becomes 15,000 delta square is equal to half हजार से ठीक है then you get a standard form just like suppose A delta square plus B delta plus C this is a standard equation of quadratic equation solution how many solutions delta is equal to